Hey everyone, in this video we'll see that how we can delete any node from the beginning of a singly circular linked list at O of one time. Let's start. So for deleting anything from the first position of a singly circular linked list, we'll take the last node instead of first node. So as you can see that we have written we'll take last node instead of head node. Then last next will be head, and for that our time complexity will be order of 1 instead of order of n. So how we can do that? Let's see. So as you can see in my screen that one singly circular linked list is written over there, and what we'll do, we will just assign FFF2 over here. So it means a node will be pointing to this node, that is last next next. And then what we have to do, we have to deallocate this memory. This is very much simple. So what do we have to do? At first we have to discard this connection, then we have to deallocate this memory, and then it will be done. So you can see that we have deallocated this memory. Now let's look at the code. As you can see in my screen that I have declared a del pointer. Now at first what we are doing, we are checking that last next equals to last or not. So it means we have only one value within our list. Let's say this is 10, the address of this first node is A, and it's pointing to the same node. If our last next equals to null, then what we'll do, we'll just put last into del. So this is the pointer del which will be pointing to this node. Then we'll set last equals to null. So it will be pointing to this node, and then we'll just set last equals to null. Else what we'll do, let's assume that we have 4 nodes or 3 nodes, A, B, C, 1, 2, 3, B, C, A. This is a singly circular linked list. Then what we'll do, we'll just put del equals to last next. So what does it mean? Del, this is a del pointer. So this del will be pointing to the last next, which will be the head. So this is the last. So what will be the last next? It will be head. So del will be start pointing to this node. Now what we'll do, we'll just put last next equals to last next next. So what do you mean by last next next? What is the value of last next? That is A, right? We'll just put last next. So let's say that what is the value of C next? It was A, right? C next, that is A. Now what is the value of C next next? It will be C next. What is C next? That is A. Now what is C next next? It will be B, right? So we'll just put B over here. It means our last node will be pointing to the second node, that is this. Then what we'll do, we'll just deallocate this memory. So here should be one curly braces, so or here. So at last we are deallocating the memory, so I have missed the curly braces. So this is how we can deallocate any memory from the first position of a singly circular linked list. I think this portion is clear. If you have any doubt, just write in the comment section. Now we'll look at the code. So as you can see in my screen, we have an insert function, we have a traverse function. I have already discussed about these things. So this is a function for deleting anything at the beginning. So if we don't have any value within a list, we'll just print no data present in the list and we'll just return. If we have one or more than one value, then we'll execute this portion. Then what we'll do, then we'll just check that if our last next equals to null. If our last next equals to null, it means we have only one value within a list. We'll just put del equals to last, we'll just put last equals to null, then we'll free the del. If we have more than one value within our list, then what we'll do, we'll just put del equals to last next, then we'll put last next equals to last next next. It means we are adding the address of the second node at the last node because we are deleting the first node. So let me compile this code. 10, 20, 30. So it means we are inserting 3 values. So as you can see in my screen that at first what we are doing, we are traversing the list, the node present in the list, that is 10, 20, 30. Then we are deleting the first node, then node present in the list, that is 20, 30. Then we are deleting 20, it means node present in the list, that is 30. And at last, after deleting the 30, we are printing that no data present in the list. So as you can see that we are calling this delete at beginning 3 times. And for the more simplicity, we can print if deleting \n\t for the best practice \n, then we'll just put del data. Let me compile this code. 10, 20, 30. So as you can see in my screen that how many data we have 10, 20, 30. At first we are deleting 10, not present in the list, 20, 30. Then we are deleting 20, not present in the list, 30. Then we are deleting 30, no data present in the list. So this is how we can delete any element from the beginning of a singly circular linked list. I think this portion is clear. If you have any doubt, just write in the comment section. See you in the next video.